All right, this is General Physics, UT Quest problem, and full parabola projectile motion. This is the football place kicker clearing the crossbar. And this is what we're given. We're given the distance the crossbar is away from the kicker. That's a horizontal distance, so call that d sub x. We're given an initial velocity, that's a two-dimensional quantity, and we're given the angle theta. So what are we going to do with this problem? Okay, the trajectory of the ball is given, but I don't know exactly where the apex is. We cannot assume that the apex occurs right over the crossbar. Right here, I've just drawn this apex. It occurs before the crossbar. It could occur after. It doesn't really matter in this problem. The main thing is we can't assume that the apex is right where the crossbar is at. So the big thing that we need to find here, like in most projectile motion problems, is I want to know the time that it takes to get from the time it was kicked and at what time in this parabola will I reach the crossbar? In other words, what time is it going to take to get right here? Well, to get to that point right here, that is the same distance in the x. So that's what we're going to concentrate on. Now, the actual problem asks for this dimension right here that I've annotated in red. It's asking the clearance. So the clearance plus the height of the crossbar is going to be this distance in the y direction. All right, the first thing that we're going to do, as we do in all projectile motion, is we have to work in separate dimensions. So I'm going to take my two-dimensional initial velocity, and I'm going to break it up to v initial in the x. That quantity will never change. And I'm going to break it into initial velocity in the y direction. All right, whatever problem you're doing, this is always a good practice. Okay, fortunately, I'm given this distance in the x. I really only have one equation in projectile motion that I can use in the x direction. Distance in the x is equal to v initial in the x times time. Now, I know all of these quantities, so I can find this time. Now, let's take a careful look at exactly what time that I'm finding. I am finding the time that it takes to follow this path. Right, it's going to go in this parabolic arch over to the crossbar. Now I know the distance in the x, but the distance in the y is constantly changing. But it doesn't matter because the time to travel in both dimensions is the same. So when I solve for this t, I found this t to reach the crossbar in both the x and y dimension. All right, now once I have this information, then I can plug it into this equation, this kinematics equation, and I can find my distance in the y as a function of time. Now, I know all these quantities, so I can just plug it in. Now, one common mistake I've seen a lot of students make is g, they forget to make negative. That is a negative quantity in the y direction. All right, so this helps me solve for this d sub y, but the problem doesn't ask for d sub y. It asks for the clearance above the crossbar. So if I take d sub y and subtract the height of the crossbar, then I have this clearance distance, and that's what you want to enter in as the answer. Okay, now let's look at part 2 of the problem. Is the football rising or falling as it goes over the crossbar? All right, well, how do I know this? How am I going to figure this out? Well, what I'm going to do is I want to know the velocity in the y direction as it crosses over the crossbar. Now, if this quantity I calculate happens to be positive, then that means the ball is rising. If the quantity I calculate is negative, then that means that the ball is falling. It's rising then that means that the crossbar is located before the ball reaches its apex. Otherwise, the ball is reaching the crossbar after its apex. If my velocity in the y direction has to be 0, then that means I'm crossing the crossbar right at the apex of the parabola. All right, well, what equation am I going to use to find velocity in the y? Well, v final in the y And I'm not finding V final at the impact. I'm finding V final when it crosses the crossbar. So that's why I'm going to use this T that I have found previously in the earlier part of the problem. Again, don't forget to make G negative. And then when I calculate V final, I look and see whether it's positive or negative, and then enter the appropriate response into the UT Quest problem. And good luck with this problem. Just watch your signs of your quantities carefully, and this shouldn't be an issue.